Hello everyone, this is DSA Zindabad. Today we are going to solve the 15th question of our virtual DSA sheet, and the question is maximum points you can obtain from the cards. Now let's look at the problem statement. There are several cards arranged in a row and each card has an associated number of points, right? The points are given in the integer array card points. In one step, you can take one card from the beginning or from the end of the row. You have to take exactly k cards. Your score is the sum of the points of the card you have taken. Given the integer array, card points, and the integer k, return the maximum score you can obtain, right? So now let's analyze the problem statement. Basically, we are given an array, right? And from this, we need to maximize the score. And we need to keep this thing in our mind. Like in one step, we can take one card from the beginning or from the end of the row. We can't pick the cards from in between, right? There is no such condition. Let's take this example. Right, it's 1, 2, 3, 4, 5, 6, 1, right? So this is our array, right? So the question says you can pick the element from the starting, right? You can pick, let's say, in this, we have given k equal to 3. So we can pick the element from the start, right? Let's say we pick all the three elements from the starting. And from there, we can also pick the element from the ending also, right? This can be considered, but we can't pick element in between. This is not required, right? This is not possible. And we can also pick the element like this. Let's say if we pick first element from the beginning and two element from the end, this is also accepted, right? So we need to keep this thing in our mind. Like we need to pick the card from the beginning or at the end of the row. You have, and we need to take exactly k cards, right? Now let's talk about the possible number of combination which we can have. First combination is either we can pick 1, 2, 3 from beginning, from start, right? Either we can pick all of these elements, which is 5, 6, 1. This one is the first combination, this is the second combination, and third combination can be either we can pick one and the two element from the end, right? 1, 6, 1. Now from all of this, we need to maximize our score, right? We need to maximize the score. So let's try to sum all these elements, which will be equal to 3 plus 2 plus 1 equal to 6. Now this will be equal to 1 plus 6, 7, 7 plus 5, 12. And this will be equal to 6 plus 1 plus 1, 8. So from all of these, we can see like 12 is the maximum answer which we can get. So as we can directly see over there, after the first step, your score will always be 1. However, choosing the rightmost card first will maximize your total score. The optimal strategy is to take the three cards on the right, giving a final score of 1 plus 6 plus 5 equal to 12, right? So from this given array, we need to pick the three elements from there, right? These three elements, which will give us the maximum result, right? So now let's talk about the second example. Let's look at the second example also so that you guys have a better understanding of the problem. So now in this array, we have given the array to be the same, which is 2, 2, 2, right? So, and for this, we have k equal to 2, right? So, regardless of which two cards you take, your score will always be 4, right? Because either we can pick the first element or the end element, either we can go for the first two starting element, either we can go for the rightmost starting ending elements, right? So ultimately our score will always be equal to 4, no matter how we are choosing the elements from the given array, right? So now let's look at the third example also. So here we have given the array 9, 7, 7, 9, 7, 7, 9, and we need to choose exactly k equal to 7 cards from the given array, right? So we need to take all the cards so that our score is the sum of all the points of all the cards. So ultimately our sum will be 55 because we need to choose all of the cards because k is 7 over there. Right. So now let's jump into the approach and try to figure out how we can solve this problem, right? So first of all, let's talk about the brute force approach. brute force approach. Let's take this as our example: 1, 2, 3, 4, 5, 6, 1. Right. So initially, what we can do, just think about the brute force approach. Like try to find out all the possible find out all possible combinations. Right. So from the required array, uh, since k equal to 3, so we can either pick the first three elements, or either we can pick the last three elements, or the third possible combination can be either we can pick the first element or the last two elements. And the fourth combination can be either we can pick the first two element or either we can pick the last element, right? So from this, we can came across like we can have four different possible combination, which are 1, 2, 3, first possible combination, and the second one is 5, 6, 1, and the third possible combination can be 1, 2, and 1, and the fourth possible combination can be 1, 6, and 1. And in the like above example, we need to consider this case also, which is 1 to 1 over there. I forgot to add fourth case over there, which is 1 to 1, which will ultimately be equal to 2 plus 1 plus 1, 4, right? So just add the fourth possible combination over there also, right? So we can have four possible combination, right? So out of these four possible combination, we need to maximize our result, right? So now just try to sum all these elements. So these all are k element, right? K element, and its sum will be equal to 3 plus 2 plus 1, 6. Its sum will be equal to 12. Its sum will be equal to 4. Its sum will be equal to 6, 7, 8, right? From these, we need to find out the maximum, and the maximum is 12. So 12 will be our answer. So whenever we try to generate each and every possible combination, it will require, each combination will require big of k time, right? And moreover, will have how much of the combination over there? Big of k, up to so on, plus big of k, big of n, right? Because we can have n different possible combinations over there from the given required array, right? So from this, we can directly see if our k becomes n, then ultimately our time complexity would become big of n square in this case. Since we are not using any extra space, so our space complexity will be equal to big of 1, no extra space, right? I hope this brute force is clear to all of you guys. Like you just need to find out all the possible combination and try to just sum up all the elements from the given combination and just maximize the result, right? Just take out the maximum from all of those given values. So now let's try to uh, optimize this approach, try to reduce the time complexity so that we can get our optimal answer, right? Optimized approach, sorry. So now let's talk about the optimized approach. Right. So now let's take this example, which is 1, 2, 3, 4, 5, 6, 1. This is our required array, given array. Sorry, this is a nums array, right? And k is equal to 3 over there. So 1, 2, 3, 4, 5, 6, 7, right? So now this is our array, right? We just need to find out different possible combinations. So when we are at I equal to 0, so first possible combination can be either we can pick this element or the last two elements, right? So so initially you'll just pick the element, the last three element, right? Now after this, you'll just pick the first element and the last two element, right? Now after this, you'll pick the first two element and the last element, right? After this, there is this combination also, like first pick the three element from the starting, right? So now, as you can see, like just try to observe the pattern, like how the array is going to look like when we pick different elements from the given array, right? As you can see, like there is some window over there which is sliding. Just observe the pattern over there. It slide down, it slide down, it slide down, it slide down. So there is some window over there. Either you can consider this white portion or as a window, or either you can consider this yellow portion can be window, right? So in this question, we'll consider this white portion to be our sliding window. This approach is known as sliding window technique. So I'll also tag the link for the sliding window so that you guys have a better understanding and just read the article about sliding window, right? I'll try to make you guys understand how sliding window is applied over there in a question, right? So in this question, we are going to consider this white as our sliding window, right? So as you can see, this window is sliding, right? And how it's sliding? So now, what we'll be doing, we'll just try to calculate, since we need to maximize the result of this yellow array, right? Maximize the sum. So either in order to maximize its sum, we need to minimize its sum, right? Just think it in a logical way, right? Because we need to maximize the result of our yellow array. The yellow array is are the number of the elements which we are going to pick from the given array, right? In order to maximize the result. So we need to minimize this result in order to maximize this result, right? So now what we'll be doing, we'll just try to calculate the sum. Let's say its sum will be equal to sum, right? So now after this, what we are going to do, let's denote this. This is our nums array, right? So for this, what we are going to do, its sum will be sum. So in this, what we'll be doing, sum minus, we need to subtract this element, which will be nums of 0, and we need to add this element, right? Which will be nums of 0, 1, 2, 3, 4, right? Right. So we need to add one element in the previous sum. This can be considered as the previous sum. Now let us donate this sum will be equal to x. So now in this x, what we are going to do, we need to subtract the element of nums of 1 and need to add the element nums of 5, right? So let's consider this as our y sum. So after this, we need to subtract nums of 2 and need to add nums of 6. So we are just adding and subtracting the element from the given sum, from the given array, right? We just try to calculate the sum of the white array initially. Now after this, what we are going to do, we'll just add and subtract the required element, right? So in this way, we are going to get the maximum result. So after this, after calculating the sum in each iteration, what we are going to do, we'll just try to calculate the total sum of the array, right? So after this, we'll just subtract the total sum from the from the sum, which will be equal to, let's say, something like this, total sum minus sum, and this will be equal to the sum of these three elements, right? I hope all of you get what I'm trying to tell all of you guys, right? So we are just taking big O of one time in doing so, like in just adding and subtracting all the elements in the sum, right? So it will not require big O of n time as it was in the previous case, in the brute force approach, right? So in an array question, whenever you have given some sort of like condition, just try to observe the pattern. Just try to draw the array, just do a drag over there and try to observe the pattern. Because as you can see, like there is some window over there with the help of which we get our result. Like we just try to observe the pattern of all the elements, how we are picking each and every element from the array and try to observe the pattern, right? Find out the pattern, and just after this, the problem will become so easy, right? So now let's try to code this thing up. Now, so this is our question, and C will be equal to 0. I will also be equal to 0. J sum is equal to 0, and N chord points dot size. Right. So initially, what we are trying to do, we'll try to calculate the sum of the white window. J equal to 0. C will be less than N minus K. Now J plus plus and C plus plus. Now just try to calculate the sum chord points of J, right? So now try to calculate the total sum. So we are going to use accumulate function of STL over there, which will calculate the sum of the complete array. Right. We also need to pass the parameter as 0 initially because we are going to add all the elements in the 0 itself, right? So now after this, what we are going to do, we'll try to store this in our answer, which will be equal to answer equal. We also need to declare answer over there, right? Answer, which will be equal to 0. So our answer will be equal to max of answer, comma, total sum minus sum, right? After this, while j is less than card points dot size. Now, what we need to do, we need to add and subtract the element, right? This will require big O funding. Sum minus equal to card points of I plus plus. We need to increment our I also, right? Sum plus equal to card points j plus plus, right? After this, again, we need to calculate the maximum result, right? Answer t sum minus sum. At the end of this, we just need to return our answer, and I guess we are good to go. There is a typo over there, accumulate. Now let's try to submit this code. Yeah, this code runs perfectly fine. Now let's do a dry run of the code also. And after this, we'll try to discuss the time and space complexity for the same. So now let's do a dry run. Take the same example, which is 1, 2, 3, 4, 5, 6, 1. And k value will be equal to 3 over there, right? So initially, let's have a C. C is equal to 0 initially. I is 0. J and sum is also 0, right? And N equal to 3, 4, 7, right? So now we just came to this loop and try to calculate the sum. So J will start from the 0 and it will go until C less than equal to N minus K. N will be 7. So initially what we are trying to do, we'll try to calculate the sum of these N, right? Because initially the first combination over there, as you can see, we need to pick the last three elements initially, right? So we need to pick the last three elements from there. So for this, we are going to sum all the four elements from the start of the array, right? So N minus K will be equal to initially San minus 3, which will be equal to 4. So sum will try to store the result of these four elements, which will be equal to 4 plus 3, 7, 7 plus 2, 9, 9 plus 1 equal to 10. So sum value will be equal to 10 and J value will be equal to 3 after this condition, right? And C value will also be equal to 3 over there, right? So after this, what is our condition? Like C must be less than n minus k. N minus k is 4. So we'll iterate until 3 is less than, right? Which is over there, right? So value of C will become 3 and J value will also become 3 and sum is equal to 10 over there. So we'll try to calculate the total sum, which will be equal to total sum will be equal to 10. 10 plus, I guess 12. Yeah, 10 plus 12 will be equal to 22. So now we'll try to store this in our answer, which will be equal to maximum of answer. Answer is initially 0 and total sum minus sum will be equal to 22 minus 10, which will be equal to 10. So our answer will store 10 initially. So after this, what we are trying, what we need to do, we need to subtract this element and we need to add this element in order to consider this, right? So we'll iterate until j is less than card points dot size. So j is 3 over there initially. So our sum will be equal to minus card points I plus plus. Sum will be equal to like this sum. So 10 minus this element, because our I initially is 0 over there, which will be equal to 1. And we need to add. So after this, we'll just increment our I, right, which will be equal to 1. So after this, what we need to do, we need to add the element, add this element, which is 5 over there. So nums of j over there, which will be equal to j plus plus, since we are iterating over the complete array. So we need to uh, include this in our main result. So this will be equal to 5. So our result will be something like 10 plus 5, 15, 15 minus 1, 14. So our sum will store 14 over there, and 22 minus 14 will be equal to 8, right? So our answer will try to compare the result as 12 is greater than 8. So there is no need to update the answer, right? So now point this will be uh, this will be pointing to 5, right? So after this, what we need to do, we need to consider this array. We need to consider this array, right? We need to consider this array. So after this, our C will be as it is, and our I will become, we need to, will increment our I also. So our I will be pointing to 2 over there. So again, we need to, this will be 14. So 14, we need to subtract this element. We need to subtract this element 1, which will be equal to 2, 14 minus 2, right? And we need to add this element, which is 6. This will be equal to something 14 plus 6, 20, 22, 18. So now we need to subtract it from the total sum. So this will be equal to 22 minus 18. This will be equal to 4, right? So we'll try to compare this with the answer. So ultimately 12 is greater than that of the 4. So it will store 4, right? So now the last condition, at the end of this, we need to take this array, right? We need to take the starting three elements. Starting three elements, right? So for this, what we are going to do, we'll again mm, subtract this element, which is 2 over there, from the our answer 18 minus 3, plus what we need to add, we need to add this element. So our j will be pointing to 6 over there. So 1. This will be equal to 19. 19 minus 3. This will be equal to 16. So 22 minus 16 will be equal to 6. 22 minus 16 will be equal to 6. Since 12 is still greater than that of the 6, so sum will be equal to now 16, right? I hope this diagram is clear to all of you guys. Initially, what we are trying to do, we'll try to calculate the sum of the initial start of the array, right? Now after this, we'll just try to add and subtract all the elements from the required array, right? This thing. So now let's try to discuss the space and time complexity for the same. Since we are just iterating over the array, so it will require big of n time. So it will also require big of n time. So ultimately our time complexity would boil down to big of n, and space complexity will be big of n, since we are not using any extra space, no extra space. I hope this approach is clear to all of you guys, and also the diagram. Uh, Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.